All right, so rectangle word problems is the subject for the day. These are going to use everything about factoring and finding the zeros that we've done so far. So let's just quickly review. If you have a problem like negative 7x squared plus 14x equals 49, how do you solve this? How do you solve a problem like this? Well, the first thing to remember is you want one side to equal 0. Right? So one side must equal 0. So in this case, we would have negative 7x squared plus 14x minus 49 equals 0. Right? Just by subtracting 49 from both sides. Another thing to remember, we must have a positive a. So in this one we would multiply through by negative 1 on both sides of the equation, giving us 7x squared minus 14x plus 49. 0. And then the last thing to remember is factor out any GCFs. So anything that these terms have in common, you want to be sure to factor out. So in this case, we'd pull out a 7. And actually, in this case, I would just view it as dividing by 7 on both sides. So 0 divided by 7 is still going to be 0. And then over here we'll have x squared minus 2x plus 7. And I don't think you can actually factor this. But from there, then we would use our Gary's terrific trick to finish solving. This one's impossible. And sometimes they will be impossible. Okay. So let's just remember that as we look at a rectangle problem. And the trick here is going to be, you may not see how these connect at first, but I'm hoping you're going to have like an aha moment in the next couple minutes. So if we had a problem like this, the length of a rectangle is 3 inches more than its width. If the area is 40 inches squared, what are the dimensions? By dimensions, I mean the width and the length. So let's draw what's going on here. We have a rectangle. It's going to be longer than it is wide. And if we call this the width, W, then the length is going to be what? W plus 3. And when we do it this way, we only have one variable, which is what we want, right? We could just say W and L, width and length, but we're not going to end up with a problem that we can really solve by doing that. And so what we want to do is just call this the width, and the length we know is the width plus 3 inches. The other thing thing we know is that the area is 40 square inches. How are we going to find the width here? What can we do? What do we know about the relationships between these things? This information that they've given us. Yeah?
Multiply, so W parentheses, W plus 3, parentheses, equals 40.
Yeah. So what formula did Graham just use? Well, he used the formula width times length equals area. Right? This side times this side should equal the area of this rectangle. It's really important that we put parentheses around this. It's not just W times W and then plus 3. It's W times W plus 3. Two separate factors. And now, if we distribute this, we're going to end up with quadratic. W times W is W squared. And W times 3 is 3W. Equals 40. So we have a quadratic. We know how to solve quadratics like this, right? We've called it finding the zeros. We haven't necessarily always called it solving. But we know how to solve this. We need to get the 40 over here. We'll subtract 40 from both sides. W squared plus 3W minus 40 equals 0. So that we have one side equaling 0. We're going to check to see if there's anything we can factor out or we need to factor out. In this case, there's not. And this 1 in front of the W squared is, kind of the reason for that. So we're just going to try to find factors of 40 that add up to 3. Or sorry, factors of negative 40 that add up to 3. So we need to start thinking. Let's see, 1 and 40, no. 2 and 20, no. 4 and 10. How about 8 and 5? Okay. So we're going to have W, which one should be plus? Yeah, the 8, because we want a plus 3W in the middle. W plus 8 and W minus 5 equals 0, which means W equals either negative 8 or 5. Wait a second. I thought we only had one rectangle. How come I have two different answers here? What's going on with that? What am I looking for? I'm looking for the width of this rectangle. So one of these answers doesn't make any sense. Yeah, the width of a rectangle can't be negative 8. So the width must be 5. And if the width is 5, what's the length going to be? 5 plus 3, which is 8. Okay, so since it's a word problem we'd want to answer in words, we could say the width is 5 inches, length is 8. That's our answer. And we're done. That's a rectangle problem. The only thing that's really new is this first step of setting up this quadratic. And then the rest of it is stuff that we've seen before, done for homework, practiced in class, just applied to rectangles. All right, let's do one more example. Questions? This makes sense? do one. This is a little bit different, but again, we're going to try to set it up as a quadratic somehow. So we have a picture frame. Has the dimensions 8 inches by 12 inches. The area of the frame is equal to the area of the picture inside the frame. And then the question is, if the frame has a uniform width, so that means the width is the same all the way around, what is it? So we're going to try to draw a diagram of this. We have a picture frame. Right? We know this side is 8 and this side is 12. And we know inside of it there's a picture. Okay. We're trying to find this width here. W. This is the width of the frame, right? Now, what we know is that this area right here is equal to this area around the frame. So we'll say area and area, which means the total area is going to be 2 times this smaller area. Okay. And we know the total area is 8 times 12 because that's how we find the area of this large rectangle. So 8 times 12 equals 96. This is equal to the total area. Since this area equals this area, half of this must be the area of this frame. So 1/2 of 96 oh, I messed up. Oops. Okay. Scratch all of that. Well, actually, only a little bit. It's the picture. So a picture has dimensions of 8 by 12. The area of the frame around that picture. Okay. So it's not this, it's the picture inside. This is 8 by 12. Okay. And then this area is still equal to that area. So this now is actually the area of the picture. And then to find the area of the frame, we would the area of the frame would be equal to 96. To find the area of the total thing, which is now what we want to find, because we need to find the length and the width, we would multiply this by 2. So 2 times 96 is 192. And this is the total area. Okay, what do we know about the width here? Like the width of this total, let's call this x. So the width of the frame we're going to call x. What do I know about the width of this total thing? Like from this edge of the frame to this edge of the frame. I know a part of it is 8. And then how much bigger than 8 is it? We don't know exactly, right? But think about it. If this is 8, how much is this from here to here?
8 times 2? No?
What if we called the width of this frame?
8 plus x.
Yeah, this would be x. Okay, but is 8 plus x the full width?
8 plus 2x.
Right, it has to be 8 plus 2x. So this side right here is going to be 8 plus 2x. It's the area of this picture inside plus the width of the frame times 2. So let's do the length the same way. The length is 12 plus, how long is this? We know the frame is the same width all the way around. So this is going to be x, and this is going to be x. And so our length here is 12 plus 2x. Okay, we know that the length of this times the width of this has to equal the total area. So now we can set up our equation. 8 plus 2x times 12 plus 2x must equal 192. So now we're going to FOIL this. I'm just going to write it here because I have it written down. So it's going to be 4x squared plus 40x plus 96 equals 192. If we subtract 192 from both sides, what? Yeah. So this is just FOIL from here to here. If we subtract 192, our quadratic becomes 4x squared plus 40x minus 96 equals 0. Let's move up here. Luckily this has a greatest common factor, so we can divide everything by 4. We'll get x squared plus 10x minus 24 equals 0 divided by 4, which is still 0. And now we can solve this quadratic. So we need factors of 24, of negative 24, that add up to 10. 12 and 2. Which one's going to be negative? Yeah, so it's going to be x plus 12, x minus 2. So x either equals negative 12 or 2. Which one of those makes sense? What is x? X is the width of a picture frame. Can that be negative 12 inches? No, that wouldn't make any sense. So it must be x equals 2. And well, that's exactly what they're asking us for. So the frame's width is 2 inches. Well, yeah, they're not asking for the, like, they're asking
Line.
just for the width of the frame itself. Does that make sense? Not for the
Oh.
total dimensions
Yeah.
of the frame.
Yes.
Right? But you're right. If the question had said, what are the total dimensions of the frame, or something like that, which it's a little bit confusing, the wording on this. Then you would have to do 8 plus 4, which would be 12 inches by 12 plus 4 is 16. So it would be 12 by 16 inches. This is not the only way to solve this problem, actually. So there are other ways that you could have set this up and gotten to the same answer. But this is a good strategy because you will probably see another problem like this at some point, where you have to think of this extra border as being x. So sometimes you'll see these problems with, like, someone has a garden and they're building a fence around the garden or something like that. Or, you know, there's a room with a carpet in the middle of the room. It could be anything that has a big rectangle with a small rectangle inside of it. And usually the key is going to be, okay, I know that this width here, that the length from the edge of this inner rectangle to the edge of the outer rectangle is going to be called x. And that's usually going to be the way to solve problems like this. And then you set up your quadratic, FOIL it, etc. Okay. Let's do one more. This is going to be kind of a silly example. But I think it shows something that's kind of cool. So, a rectangle has the same width as length. So the width and length are the same. If the area is 64, what are the dimensions? Let's say 64 square centimeters. What are the dimensions? So we've got a rectangle, which, what else might we call this rectangle?
Square.
A square, because the length and width are the same. Now the cool thing about this is you're going to be able to set this up the same way that we set up that first problem. So we've got our square, and we know the sides are x, because we don't know what they are. And we know the area is 64. So let's set this up the same way that we set up the first problem. It's going to seem a little silly at a certain point, but I want you to kind of bear with me. So we multiplied the length times the width. So x times x, right? We might have put them in parentheses. And that equals the area. Now what is x times x? That's just going to be x squared equals 64. Now, bear with me here. The next thing we did was we subtracted that off, right? So that we had 0 on one side. X squared minus 64 equals 0. That's a difference of squares. So we're going to have x minus 8 and x plus 8 equals 0. So x has to be 8 or negative 8, but the negative 8 doesn't make sense. And so our answer is going to be the length and width are 8 what? Yeah, never leave your unit off. Always remember your unit. If you said that length and width are 8, You did the math right, but I would still take points off. Okay, because you didn't have the centimeters there. So the length and width are both 8 centimeters. Now, I think the cool thing about this is it helps you really understand what a square is, right? There's a reason that we call this squaring, because it's literally a square. X squared is the square based off of x, right? And that's where we get this difference of squares. And it's the difference of these two squares. So it's kind of cool to look at it that way. And again, these same steps are used for the rectangle. It's just when we have a rectangle, we're going to have to factor a little bit differently, because you'll have an extra. All right, we did it. I know that was a little long.